This video is going to cover section 2.1 in Stats 1 on stem and leaf graphs, sometimes called stem plots. We're going to talk really briefly about line graphs and bar graphs at the end, but mostly we're going to talk about stem plots in this video. So chapter 2, part 1, by the end of this chapter, you should be able to display data graphically and interpret graphs, stem plots, histograms, and box plots. Those are sections 2.1 and 2.2. Recognize, describe, and calculate the measures of location of data, quartiles and percentiles, that's 2.3 and 2.4. Recognize, describe, and calculate the measures of the center of data, the mean, median, and mode, those are sections 2.5 and 2.6. That's going to actually be in Unit 2. And then recognize, describe, and calculate the measures of the spread of data, the variance, the standard deviation, and range. That's section 2.7. So like I said, I'm splitting. So these are all the different things. We have part that's in Unit 1 and parts that are in Unit 2, but this is the overview of all of Chapter 2. So statistical graphs help us learn about the shape or distribution of a sample or a population. The visual nature of a graph can be a better way to look at our data than a mass of numbers because we can see where the data clusters and where there are only a few data values. Newspapers and the internet use graphs to show trends and to enable readers to compare facts and figures quickly. I think, graphics, all the different kinds of graphs that we see every day are like hugely important to be able to create them, to be able to read them and interpret them, to understand them. These are two that I pulled off the web, projected career earnings for college graduates and here's all these different industries. And then we're going to talk about percentiles later, but the 10th percentile, the 25th, which is the first quartile, the median, the 75th percentile, and 90th percentile. So this shows you the different ranges of salaries that you could expect to make in these different industries. So visually, it just helps you more than just looking at a table full of numbers, say. And over here, we have annual ticket sales by league. And so obviously, right off the bat, we can see that Major League Baseball has a much higher annual ticket sales than even the NFL, which sort of surprises me, but maybe there's just a lot more teams or, who knows why. But again, these graphs help us see visually the data instead of just looking at a table or some other just numerical representation of our data. So stem and leaf graphs or a stem plot is a good choice when our data sets are small, and we'll see why that's true. To create the plot, we're going to divide each observation of data into a stem and a leaf. The leaves consist of your final significant digit. So for example, the number 23 has the stem 2 and the leaf 3. So that last digit is our leaf. The number 432 has the stem 43 and the leaf is 2. Again, that last final digit. Likewise, the number 5,432 has a stem 543 and the leaf is 2. And the decimal 9.3 has stem 9 and leaf 3. So it's always that last digit, that's our leaf. Everything else is our stem. We're going to write our stems in a vertical line or column from smallest to largest. And then we draw a vertical line to separate, so to the right of the stems, to separate the stems from the leaves. And then we write the leaves in increasing order next to their corresponding stem. We want to, we'll look at that in a second. We want to make sure we include every leaf. So even if there's repeats of a number, if you see it more than once, you're still going to write that leaf multiple times. The stem you only write once. We're going to see an examples of this. If there are no leaves in between two stems, we still include that sort of blank line so that we can see that there's missing or data that's not on that row for that stem. And again, that'll show us gaps in the data. So let's look at this example. So for the Park City basketball team, scores for the last 30 games were as follows from smallest to largest. And here they are, 32, 32. See, we have a repeat there, 33, 34, etc. Notice there's no 41. We have some 50s and some 60s. So there's no gaps in our stems here, which I do think there's an example of later. But we're going to open Excel now. And what I didn't show you a second ago is this might look similar to what you have on your Canvas site, but here I'm working on this PowerPoint right now, clicking through it. And here are all of our example worksheets. I'm actually going to use one that has all of them together. So your Canvas site might look a little bit different than what I'm showing you right now, but the examples will be the same. They just might be in one Excel sheet versus these different ones. But if you click on this little arrow here, it will download that Excel for you, and then you can follow along. So I already have this one open that has all of the different sections down here on the tabs. And here is Try It 2.1. And so that is the one we're working on right now, Try It 2.1 for the Park City basketball team. So if you had to do it on your own, you would open Excel maybe to a blank page, tab in your workbook, and you would copy the data. You want to have your data in one row or one column. Put it in a column if you want Excel to sort it for you. Sort the data if it isn't already in ascending order, so lowest to highest. And then we'll list the stems in order from smallest to largest going down the sheet. And then we're going to list the leaves going out in rows with a space in between them. Sometimes you'll see a comma in between them. It depends on how you want to show your data. And we're going to use the borders in Excel to make the vertical and horizontal lines. Okay, so back over here, I have the data in here for you. And so stem and leaf. So you might have to create this yourself if you weren't working on something I had made for you already. And so my stems here, I see I have a couple of 30s, so I'm going to have 3 for that stem. I have some 40s. If I scroll down, I'll see my 50s, and further still, and I see I have some 60s. So I'm going to hit enter. I'm going to create my border. So between stem and leaf, I'm going to put a border. So over here on the home menu, here are the borders. And I am going to do a right border. So that put a border in between the word stem and leaf and all the way down here because I had those highlighted. I'm going to actually go down to my line style. I'm going to make it a little bit thicker and click on that again. And see, it's just a little bit thicker. You don't have to do that, but if you want to just have it be a little bit thicker. So now I'm going to do the bottom border. So I'm going to highlight stem and leaf, and I'm going to click bottom border. Now, I don't know if it'll automatically, it kept that same width of my border. So keep that in mind as we move on in the examples. So it is now defaulting to that thicker border. Okay, so my leaves, I have a 32. So I'm going to put 2. So that's my first 32, a space, and another 2. That represents my second 32. Both of these are represented. Now I want to include my 33. So over here, 3, space, 4 for my 34, and 8 for my 38. So in the 30s, I have a 32, a 32, a 33, a 34, and a 38. And over here, I have 2, 2, 3, 4, 8 to represent all of those leaves from those data values I have over here. For my 40s, I have 40, so just a 0. I have a 42 and another 42. I have a 43, 44, 46, 2 47s, and now I have 2 48s and a 49. For the 50s, I have 50, another one, 51. I see 2 52s, and if I scroll down a little bit more, 1, 2, 3, I have another 52. I know it gets hard to see. Then I have a 3, a 4, a 6, and 2 7s. So a 3, a 4, a 6, and 2 7s. Now I can double check, right? I can see that I have up here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in the 50s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in the 50s. Okay, it's a good idea to double check your data and how you've put it in to make sure that you're not missing a data point. And then in the 60s, I have a 60, so 1, 0 for my 60, and then a 1 for my 61. So we'll talk about this some more as we go through the slides, but you can kind of see it looks like the 40s and the 50s. I have the bulk of my data. There's no big gaps between the stems. I can see what value is the most common. I can see the mode here. So here, 52 occurs 3 times, so that's my most common value. We'll talk about modes some more later. 57 happens twice. 48. So you can start to get a sense of your data visually from this stem and leaf plot. Okay, so a stem plot is a quick way to graph our data. It gives us an exact picture of our data. It helps us look for overall patterns and any piece of data that does not fit in with the rest of the data. Those values, data that doesn't seem to fit in with the rest of our data, we call those outliers or extreme values, and they could be on the low end or the high end. Some outliers are due to mistakes. For example, if I had written down 500 instead of 50, so for this example, I had 2 50s, but maybe I put an extra 0 because I was typing. While others might indicate that something is unusual happening, and we might want to look into that a little bit more to see what's going on. So in this data, are there any concentrations of data or outliers? I don't see any outliers here. And like I said before, there's a lot of 40s and a lot of 50s, with 52 being, oh, I'm sorry, I said 52, but 48 occurs 3 times as well. Let me just go back to Excel to make sure that's what looks like. I only have 2 48s here. And when I go to this data set, in my Excel sheet, I have a mistake. See, there's 3 48s here. And then when I did it in my Excel, I missed one. So I'm actually going to just, I'm going to right click here and I'm going to insert. And it says, well, what do you want to do? Whoa. And I'm going to shift all my cells down. Okay. And I'm going to add in another 48 there. And then I'm going to go up here and double click up here, or click up here and just add another 8. So see, it's always good. Like I probably should have counted each one of these to make sure I had the right number of data points. So, all right. So that kind of also showed you how you can insert something if you make a mistake and forget a piece of data. All right. So back to our slideshow. So lots of 40s, lots of 50s, doesn't seem to be any outliers. So this example 2.2, the data are the distances in kilometers from home to local supermarkets. We're going to create a stem plot using this data. So if we go over to Excel, that's example 2.2. I put the data in here for you. It is sorted low to high, okay? And we're going to create our stem plot. So I like to write the words stem and leaf. You don't have to. I'm going to hit Control Enter so I don't go out. I'm going to put my border in to start. I don't know how far down I'm going to go. I know I have 1, and then I have some 2s, 3s, 4s, 5s, 6s, and then a 12. So 5, 6, and this is what I said before. I'm not going to put the 12 right here. I'm going to include 7, 8, 9, 10, and 11. And now there's my 12. Even though I know there's not going to be anything on those rows, there's no leaves there, that'll show me that gap in the data, which might lead me to an outlier. I'm going to highlight these cells here, and I'm going to put in that right border to separate them. Now, with decimals, you could do the decimal and the number 0.1 space 0.5 if you like. If visually you don't care for that, you want to do 1, 5 like that, you need to indicate that those are decimal values. So you could put a key down here that says 1, it depends. I'm going to do this like little slash that's up above enter, 1/1 equals 1.1, so that now your viewers know that when they see that 1, it's not 11, it's 1.1. So you decide how you want to display it. I generally put the decimals in. I just think it's less confusing because they're there. So 2.3, 2.5, 2.7. You notice that Excel was trying to do something for me. I'm just going to ignore it right now. It didn't fill it in, but there's lots of things that Excel can automatically do for you if you know what you're looking for and what it's doing. So 3.2, here I'm going to enter 3.2. I included 3.3, 0.3, 0.5, 0.8. Now onto my 4s. So I have a 0.0, a 0.2, a 0.5, a 0.5, a 0.7. Scroll down a little bit, and I have a 0.8. For the 5s, I have a 0.5, a 0.6. That's it. For my 6s, I have a 0.5 and a 0.7. And now again, nothing from 7, 8, 9, 10, and 11 until I get to 12.3. Okay. So that's what this stem plot looks like. And again, I'm going to look for concentrations of data, and I'm going to look for possible outliers or extreme values. Notice how Excel sort of formatted this differently. If you don't like this, you want it to be all formatted, in this case, to the left-hand side of the cell. I'm going to go down here and I'm going to change my format to text. And I'm going to try to get rid of the 0 just so that it looks the same. Okay. Excel gives me this little green guy up here, this little green thing. It says, uh-oh, you have a number that's stored as text, which means that like I won't be able to do numerical things with it, but it's just a graph for me right now. So that's fine. I just like it sort of like being consistent throughout my stem plot. Okay. So back over here, so this is how I did it the first time when I was making the slides. I did not include the decimal, and you see I don't have a key. This is where it becomes ambiguous. Is that 11? Is it 123? So again, either put the decimals in like I've done here, or put a key, or both. Any concentrations of data or outliers? So I can see 33, see 3.3 occurs twice, 4.5 occurs twice. Then I have this big gap, and I have 12.3. So 12.3 could be an outlier. I might have made a mistake when I collected the data, when I typed it in, or I may be just interested in that data and want to know why is it so different from the rest. We also have side-by-side stem plots, and that allows us to compare two data sets in two columns. The two sets of leaves share the same stem. So here in this one, you can see the stem is here in the middle. And then some of the leaves are on the left, and some are on the right of the stems. So this is the ages of presidents at inauguration and ages at death. So the way I would read this would be 46 and 49 are two of the youngest ages of presidents at their death. And then ages at inauguration, 42, 43, 46, etc. So the youngest age of a president at inauguration was 42. The youngest age at death was 46. Not necessarily the same president, just raw data. And then we have some presidents who died at 90, 2 at 90, and 2 at 93. The oldest president to be inaugurated was 69 in this data set. Okay, so the stem goes in the middle, and then you do your data leaves going out to the side. And you definitely need to say which one is which, okay, so you know what's going on. So we're going to try this with some coffee data. So Starbucks prides itself on its low lineup times in order to be served. A new coffee house in town has also boasted that it will have your order in your hands and have you on your way quicker than the competition. The following data was collected for lineup times in minutes for both coffee houses. So on the top row, we have Starbucks times, and on the bottom row, we have Just Us coffee times. So this came from, you can see down here, I have the link if you wanted to go look at where I got this data. So in Excel, I put this data in, okay? I'm gonna move myself up here. for now. And one of the things that I like to do, it's not necessary to sort your data. You can kind of just try to go through and do it without sorting it. You just then want to make sure that you don't miss any of your data items, right? I could just say, okay, I've got some 20s, some 20s, teens, some low numbers. So I'm going to have a 0 stem for these guys. And you could just put those stems in. If you want to sort it, you can't sort a row. It has to be a column. So I'm going to copy this data, and then over somewhere else, I'm going to right click or paste special. And you see this one here with this little like corner arrows, that's called transpose. I also get that if I right click over here. And I'm going to transpose, and that just means flip it. So go from a row to a column or a column to a row. So that's what that looks like. Now I can sort that data and I can highlight everything. It's maybe not visually appealing right now, but that's all right. I'm going to do this one. That's low to high. And then I'm going to do the same thing for Just Us Coffee. I'm going to right click and copy, or you could do Control C, but then I have to right click or do the paste special up top, transpose. It's telling me I can't use it later. That's fine. I don't need to. Let's see. Now Excel's not letting me highlight my data. Let's see. I'm going to go back here. And so that happened because I was doing a bunch of different things, and maybe I'll just hit escape. Sometimes I have trouble with my, you know what, maybe I'll try a different. It's so weird. Okay. I'm going to do Control Arrow. I'm going to highlight everything. I was just having a little bit of difficulty there. I sorted it. So now it's just a little bit easier to find my stems and put my leaves in. So I am, again, going to have a stem of 0 for those 8-minute wait times, a stem of 1, and a stem of 2. That's all I have. Now Starbucks is going to go over here on the left. So I have 2 8s, and that's it. And then I'm going to have a 1, 2, 3 12s, a 15, a 16, 17, 18, and 19. And then I have 2 20s, a 26, 2 26, and a 27. Now, the way that Excel formats its cells, I'm going to go to home here. It formats the text on the left-hand side. I don't like how that looks, so I'm going to go up here and I'm going to change my alignment so that it's starting close to my stem and then going to the left. And I'm actually going to center these guys. I'm going to change the alignment to the center. You don't have to do that. I couldn't see some of these values, so you kind of had to do something there. You could also merge your cells if you wanted. We'll talk about that at other points and different things that we do. This works for me right now. So Just Us Coffee, I don't have anything that are single digit minute wait times. So I have 3 10s, a 12, 13, 1, 2 15s, 2 16s, and a 17. I have 1 20-minute wait time, 22, 2 of those, a 24 and a 29. Okay. I'm actually realizing I did these totally backwards. You got to go low to high going out. So I'm going to change that again, and I'm going to start with my 19 and go to my 2. So I'm going to do 19, 18, 17, 16, 15, 12, 12, 12. That way the small numbers are in the middle near the stem, and then the bigger numbers go out. Sorry about that. Just about to do the same thing here. So 7, 6, 6, 0, 0. So just remember that when you're typing them in. So now I can read this. There's 0, 8 minutes, 8 minutes, 12, 12, 12, 15, 16, 17, 18, 19. On the other side, I have 10, 10, 10, right? So again, I'm looking for concentrations. I'm looking to see how spread out the data is, any outliers. Starbucks has these 2 really short wait times, and Just Us Coffee has the highest, one of the highest wait times down here at 29. So if Just Us Coffee is saying that they have better wait times than Starbucks, I don't know if that's true. There's other things we can do with the data to make that determination. This is just a quick way to look at it. All right, so we made a side-by-side stem and leaf plot. Remember, the left-hand side will be in descending order and the right-hand side will be in ascending order. If you have a single-digit datum, the stem will be 0, and that was for those 8-minute wait times that we had. So one thing to note too, when a stem has many leaves, you can sometimes want to split the stem into 2 lines or more. So if you do 2 lines per stem, you're going to put the leaves 0 through 4 on the first line and the leaves 5 through 9 on the second line. So just, I don't have an example of this, but here, you know, you could do 0, all those 10s, 12s, 13s on one line and then have another. Let me see if I can insert this and shift everything down. So I could have another 1 here, and then I could do 5, 5, 6, 6, 7. You would then want to have, you know, make sure I clean this up and get rid of those 5s and 6s. It has to be consistent throughout. So if I did that, I would have to do, make sure 9, 8, 7, 6, 5. Clean up the one above. A little tricky going backwards there. I would have to do it for every row. Okay, so I would need another 2 here. I didn't center that one. This would have just the 9 from above. And change the alignment on that. This one would have 7, 6, 6. And I would get rid of those guys. Right, so maybe you don't need it for this, maybe you don't like how that looks, but if you wanted to split it up because you had a lot of data, that would be one way you do it. So the leaves 0 through 4 on the one above, 5 through 9 on the one below. So these show each of the original or truncated data values. By looking at the display sort of sideways, you can see the distribution, the shape of your data. We're going to get into that a little bit more, but if we look over here, you know, it goes low. I've got my head turned, low, high, low. So that's a little bit of a bell curve here. This has a little bit of a skew, you know, so we're going to be talking about that later. But you got to look at it sideways to see that. And then if there are large gaps between stems containing leaves, especially at the top or bottom of your display, the data values in the first or the last lines might be outliers, and you want to make sure these aren't data errors. We've already talked about that a bit. You just want to double check those, make sure you collected them correctly, wrote them down correctly. And again, it might be something you just need to look into more because it's just interesting data. So that's it for stem and leaf plots. Like I said, briefly going to talk about a couple of other graph types. Here's a line graph. In this particular one, the x-axis, your horizontal axis, consists of data values, in this case, the number of times a teenager is reminded. And then going up, the y-axis, the vertical axis, consists of your frequency points. The frequency points are connected using line segments. So we're connecting each of those. So 0 times a teenager is reminded, that happened twice when you collected your data. Teenagers reminded once, that happened 5 times when you collected your data. They were reminded twice, 8 times. They were reminded 3 times, 14 times. They had to be reminded 3 times. They'd be reminded 7 times. 7 times they had to be reminded 4 times. You get the picture, and then you connect them by lines. So that's a line graph. And then bar graphs consists of bars that are separated from each other. We saw this when we did the bar graphs and the pie charts before. Your bars can be rectangles or they can be rectangular boxes used in like 3-dimensional plots. And they can either be vertical or horizontal. This bar graph here has age groups represented on our x-axis and the proportions on the y-axis. Okay. So that was it for section 2.1. Thanks.